Hi students, this is Miss Paula, Mr. Damiani, student teacher. Today we're working on lesson 9.2, equations and tables. Essential question is how can you translate between equations and tables? When an equation describes the relationship between two quantities, the variable x often represents the independent variable, and y often represents the dependent variable. A value of the independent variable is called the input value, and a value of the dependent variable is called the output. So if we look over here, we're saying if 2 is equal to x, if you replace the 2 with the x, your output will be 5. Okay, so let's read Unlock the Problem. A skating rink charges $3 for each hour of skating plus $1.75 to rent skates. Write an equation for the relationship that gives the total cost, y, in dollars for skating X amount of hours. Then make a table that shows the cost of skating for 1, 2, 3, and 4 hours. We're going to read over here. What is the independent variable? What is the dependent variable? So if we look back, the time in hours is X. And the total cost is Y. So the total cost is our dependent variable and our independent variable is X. So over here, the total cost, Y, is $3. We're going to write $3. $3 for each hour, which we don't know the hours, so we're going to represent it by X, plus 175 to rent the skates. So this is our equation we'll be working with. We're just going to be replacing the X value for over here. If we look over here, this is our input. So what we're doing is we're just substituting 3 times 2. We're taking this number over here and replacing it with X. So 3 times 2 plus that fee of 175, which turns out to be $7.75. That's our output. Let me just move this down a little bit more. So again, we're just replacing 3 times 3 plus 175, and that's 1075. $13.75. So you can do this, you should be doing this work, pausing the video and doing it yourself. We're over here, if you look, replace X with each input value and then evaluate to find the output value. So again, we just substituted. Every time we saw an X, we looked at our input column and replaced it. Substitute and solve. Sorry about that. So if we turn the page, we're on 498. Okay, Jamal downloads songs on his MP3 player. The table shows how the time it takes him to download a song. The table shows how the time it takes him to download a song depends on the song's file size. Write an equation for the relationship shown in the table. Then use the equation to find how many seconds it takes Jamal to download a song with a file size of 7 megabytes. So here they helped us out a little bit. They're saying that every time you multiply this number up top by 12, you get Y, you get your output. So 12 times 6 gives you 72, and 12 times 8 would give you 96. You can download each You can find each download item by multiplying the file size, but what number? What number have we been using? 12. So the equation that we're working with, oh, let's fill this in over here. Y equals 12. Y equals 12 times the file size, which will change, so that's X. So the equation for the relationship is Y equals 12X. Step 2, use this equation to find the downloaded time for a file size of 7 megabytes. So really we're just going to substitute this X with 7. So what's 12 times 7? I'm going to do it out over here. 7 times 2 is 14. Carry this 1. 7 times 1 is 1. 84. Y equals 84. So it takes Jamal 84 seconds to download a 7 megabyte song. So number one is just explaining your answer. So if we were to go back and check, which we did, it gives the correct output value for each input value. So in order to do this, we're just going to go back to our table and check that the equation gives you the correct output. Correct output value, meaning you would go back and check your work. So you would multiply, 1 second, let me just finish writing this. So meaning if you go back, if you look at this table up here, 12 times 4, you would go back and make sure that it would be that it would equal your output value. So 12 times 4 is 48. You would just go back to your table and to make sure that your work is correct. And for number 2, compare representations. Describe a situation in which it would be more useful to represent a relationship between two quantities with an equation than a table of values. So using an equation, rather than a table is probably quicker or more efficient than using a table. Okay, so now we're going to practice a little bit. So our equation use the equation to complete the table. So really we're just, when x is 10, we just add 3 and we would get 13. We're going through these and replacing x with this value. So our output over here would be 6 plus 3, which is 9. 8 plus 3 is 11. Going on to number 2, y equals 2x plus 1. So they give you these x values over here. So we're going to go back and replace them with x. So y equals 2 times 4 plus 1. So you can go ahead and pause the video and replace these values with x. Okay, thank you for pausing. These values would be, this one would be 9. Go over here and we write it out. 2 times 7 plus 1. So 2 times 7 is 14 plus 1 is 15. Y equals 2 times 10, 20 plus 1. This is 21. So really we just substituted our x value in to get our output. We're going to move down to number 3. It says write an equation for the relationship shown in the table. Then find the unknown value in the table. So if we look at our x values, what number do you see that we're multiplying to get the bottom value? If we multiply each of these by 2, we get our y values. So our equation would look something like this. Y equals 2x. So when we multiply 10 times 2, we get the value of 20. Okay, so for independent work, I want everyone to do numbers 4 and 5. And don't forget your post-it note. And of course, any questions you might have, you can write on a post-it note as well. Have a good night. Thank you.